Selling your car to Carvana is as easy as...
As easy as pie?
Sure. All you have to do is enter your license plate or VIN.
As easy as a stroll in the park.
Okay, then just answer a few questions and you'll get a real offer in seconds.
As easy as singing.
Why not? Schedule a pickup or drop-off and Carvana will pay you that amount right on the spot.
As easy as playing guitar.
Actually, I find that kind of difficult. But selling your car to Carvana is as easy as...
Can be.
Visit Carvana.com or download the app to get an instant offer today.
This is SpaceTime Series 25, Episode 47, for broadcast on the 20th of April, 2022. Coming up on SpaceTime, discovery of a missing link in the origins of supermassive black holes. The famous Martian Meteorite Black Beauty gets a CT scan, and the James Webb Space Telescope reaches another major milestone. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have identified a rapidly growing black hole in the early universe, which appears to be a crucial missing link between young star-forming galaxies and the very first supermassive black holes. The discovery, reported in the journal Nature, is based on observations by NASA's Earth-orbiting Hubble Space Telescope. Until now, this monster, called GNZ7Q, has been lurking unnoticed in one of the best-studied areas of the night sky, the Great Observatory's Origins Deep Survey Northfield, better known as Goods North. Archival data from the Hubble Space Telescope's Advanced Camera for Surveys instrument helped the authors determine that GNZ7Q already existed some 13.05 billion years ago. That's a time when the universe was just 750 million years old. Hubble detected a compact source of ultraviolet and infrared radiation. Now, this couldn't have been caused by emissions from galaxies, but it was consistent with radiation expected from material being torn apart at the subatomic level as it's being crushed and ripped apart in an accretion disk surrounding a supermassive black hole. And it raises an important question. How could something so big as a supermassive black hole, an object which has millions to billions of times the mass of our Sun, have formed so quickly after the Big Bang? Now, computer simulations have come up with hypotheses to try and explain how rapidly growing black holes can form, especially in dusty early star-forming galaxies. The thing is, none have actually been observed. That is, possibly until now. The study's lead author, Senji Fujimoto, from the Niels Bohr Institute at the University of Copenhagen, says analysis suggests that GNZ7Q is the first example of a rapidly growing black hole in the dusty core of a starburst galaxy. He says this object's properties across the electromagnetic spectrum turn out to be an excellent match for predictions from theoretical simulations. Current hypotheses predict that supermassive black holes could begin their lives in the dusty shrouded cores of vigorously star-forming or starburst galaxies before expelling the surrounding dust and gas and emerging as extremely luminous quasars. Quasars are powerful jets of energy and matter produced by a material on a black hole's accretion disk which hasn't yet passed the event horizon. A point of no return beyond which gravity is so strong that nothing, not even light, can escape, and any matter that passes this point falls forever into the black hole's singularity. While extremely rare, both these dust starburst galaxies and luminous quasars have been detected in the early universe. The authors believe that GNZ7Q could well be a missing link between these two classes of objects. See, GNZ7Q has exactly both aspects of the dusty galaxy and the quasar, where the quasar shows a dust-ridden colour. Also, GNZ7Q lacks certain features that are usually observed in typical very luminous quasars. And this is most likely explained by the central black hole in GNZ7Q still being quite young and growing. And these properties match the young transition phase quasar predicted in computer simulations, but never yet identified in the very early so-called high redshift universe. Fujimoto says GNZ7Q provides a direct connection between these two rare populations, and so provides a new avenue for understanding the rapid growth of supermassive black holes in the very early universe. He says the discovery provides an example of precursors to the supermassive black holes observed in later epochs. And GNZ7Q's host galaxy is active. It's forming stars at a rate of 1,600 solar masses every Earth year. Now, by comparison, our own galaxy, the Milky Way, produces just one solar mass worth of stars every year. And GNZ7Q itself appears bright in ultraviolet wavelengths, but very faint in X-ray wavelengths. Now, usually the accretion disk on a supermassive black hole would be very bright in both ultraviolet and X-ray light. But this time, although the team detected the ultraviolet light with Hubble, the X-ray light was invisible, even in one of the deepest X-ray datasets. The results suggest that the core of the accretion disk, that's where the X-rays are originating, is still obscured with dust, while the outer portion of the accretion disk, that's where the ultraviolet light originates, has become unobscured. The author's interpretation is that GNZ7Q is a rapidly growing black hole, still obscured by the dusty core of its star-forming host galaxy. It's unlikely that discovering GNZ7Q hiding quite literally in plain sight within the relatively small Goods North survey area was just dumb luck. Instead, it's much more likely that the prevalence of such sources may in fact be significantly higher than what was previously thought. We just haven't been looking the right way. The authors are now hoping to systematically search for similar objects in the sky using a dedicated high-resolution survey. And of course they want to take advantage of the James Webb Space Telescope spectroscopic instruments to study objects like GNZ7Q in unprecedented detail. Once in regular operation, James Webb will have the power to decisively determine just how common these rapidly growing black holes really are. We'll keep you informed. This is SpaceTime. Still to come, the Martian Meteorite Black Beauty gets a CT scan, and the James Webb Space Telescope reaches a major milestone. All that and more still to come on SpaceTime. And time now for a break in our show for a word from our sponsor, NordVPN. Are you worried about your online privacy and that of your family? Well, so are we. And that's why we've teamed up with NordVPN to get you an affordable solution and a better night's sleep. The premise is simple. NordVPN is the world's most advanced security and privacy solution. It encrypts all your data so no one can get their hands on it. And of course, having a great VPN service gives you a whole bunch of other benefits, including having access to geo-block content, which is really annoying and so arbitrary. Plus, NordVPN is really simple to use. You deserve to browse the internet safely and securely without anyone looking over your shoulder. And with NordVPN, you get to do just that, without having to worry about your safety and privacy or that of your family. So, let's get you started. If you'd like to take advantage of NordVPN, we have a special URL with a great deal for SpaceTime listeners. Grab your exclusive NordVPN deal by going to nordvpn.com/StuartGary and use the code StuartGary to get a huge discount off your NordVPN plan, plus one additional month for free and a bonus gift. And of course, with Nord's 30-day money-back guarantee, it's all completely risk-free. It's a fabulous deal, which is why we use it. So that URL again is nordvpn.com/StuartGary and use the code StuartGary to get a huge discount off your NordVPN package, plus 1 month for free and a bonus gift. And it all comes with Nord's 30-day money-back guarantee. So, what do you got to lose? And of course, we'll include the URL in the show notes and on our website. And now, it's back to our show.
You're listening to SpaceTime. SpaceTime with Stuart Gary.
NASA and the United States Army have combined forces to undertake new research on a famous Martian meteorite known as Black Beauty. The meteorite was blasted off Mars billions of years ago as ejected from an asteroid impact on the red planet. It then floated through interplanetary space until finally getting caught up in Earth's gravitational field and eventually slamming into the Sahara Desert, where it was discovered in 2011 and named Black Beauty NWA 7034. Previous research has shown that the spaceball-sized meteorite is one of the oldest Martian meteorites discovered on Earth, and it even contains evidence of Martian water. NASA's scientists from the Goddard Space Flight Center in Greenbelt, Maryland, together with researchers from the U.S. Army Combat Capabilities Development Command's Army Research Laboratory, have been using computed tomography or CT X-ray scanning technology to look deep inside a number of Apollo 16 lunar rock samples. And they decided that while they're at it, why not examine Black Beauty as well? Military researchers normally use this equipment to study the relationships between the processing of materials, that is their microstructure, and ultimately relate that to mechanical performance. A 3D printed material can be scanned for defects, cracks, and voids, and researchers can use this information to create stronger materials. But for NASA, these scans have provided a goldmine of new processing data previously unavailable. This report from the U.S. Army Research Laboratory.
NASA officials say some rare and distinct meteorites found on Earth were actually rocks ejected from Mars after a large impact event. One such rock from the red planet made its way to an Army laboratory recently for a special X-ray look inside. Researchers from the U.S. Army Combat Capabilities Development Command's Army Research Laboratory, the Army's corporate laboratory known as ARL, have powerful tools to look deep inside metal and rock. They can see into objects and provide insightful analysis. Recently, NASA asked them to look inside a Mars meteorite named Black Beauty, a sample about the size of a baseball and weighing about half a pound.
What's unique about Black Beauty is that it's one of the oldest Martian meteorites that has been discovered on Earth, and it has been proven to have some evidence of water. That's what makes it so special.
Scientists from the NASA Goddard Space Flight Center in nearby Greenbelt, Maryland, proposed a collaborative project to look at Apollo 16 lunar samples. The Moon Project soon led to the Martian Meteorite Project.
I think there's a lot of benefits that the collaboration between NASA and ARL can provide. And in the bigger picture, ARL is now also supporting the national space policy. That's helping to advance the mission of going back to the moon and Mars. And so in that regard, ARL is helping a much bigger picture of advancing science.
Army scanning instruments provide high-resolution images at full three-dimensional volume non-destructively. Army researchers use this equipment to study the relationships between the processing of materials, the microstructure, and ultimately relate that to mechanical performance.
So with the X-ray CT scan, we can non-destructively identify voids and defects such as cracks within the material prior to testing.
For instance, 3D printed materials are scanned for defects, and researchers use this information to create stronger materials for future soldiers. For NASA, the data is a goldmine previously invisible.
Science is really intrinsically collaborative, because even just the peer review process that allows us to publish our work requires our peers to understand what we're doing, not just from a written page or a computer screen. And so collaboration, I think, starts at birth in science. And so working together with new measurement techniques that measure the previously unmeasured in things that we're barely understanding is the best way to go.
The NASA team sees this collaboration as beneficial.
You know, space is a big place, and there's a lot of work to be done. And we were lucky, thanks to partnerships between our engineers, together with colleagues who they've met through conferences at the U.S. Army Research Lab, we were able to put together the pieces and develop a partnership to start looking at extraterrestrial materials from the moon and Mars in ways that have pushed the limits of resolution.
Seaton said the entire ARL team was impressed the first time they saw the Martian meteorites.
We met in a conference room and they took it out and we were all able to put on gloves and hold it. So that was really neat. And it's just amazing that this came from another planet and then we can hold it in our hand.
Scientists from both organizations plan to jointly publish 2 journal articles later this year about the research into both lunar and Martian X-ray scans.
We are definitely looking into opening up the dynamic of this relationship that's newly forming between NASA and ARL. What we all have in common is just curiosity and an interest in what we're doing. We're all very passionate about what we do. I'm passionate about technology and new technology and anything that we can do to improve how we do things, how we look at things. And the scientists like Dr. Garvin are really interested in what can we learn from this technology from a science perspective. And I think those are the same curiosities are felt at ARL.
I never expected that this would happen. I've scanned a lot of interesting materials over the course of my years here at ARL, but have never scanned something so unique and valuable.
And in that report from the U.S. Army's Research Laboratory, we heard from U.S. Army engineer Jennifer Seatons, NASA Goddard Chief Scientist Jim Garvin, and NASA Goddard Materials Engineer Justin Jones. This is SpaceTime. Still to come, NASA's James Webb Space Telescope reaches a major milestone, and later in the science report, scientists have successfully developed a human-like sense of touch for robot skin. All that and more still to come on SpaceTime. NASA's new $10 billion James Webb Space Telescope has finally reached its planned operating temperature. With the help of what's called a cryocooler, the telescope's key mid-infrared instrument has dropped down to just a few degrees above absolute zero, minus 273 degrees Celsius, the lowest temperature matter can reach. And so the telescope is now ready for final calibration. Orbiting the Earth some 1.6 million kilometers away, James Webb is located in a gravitational well called the Lagrangian L2 position, located on the planet's night side. The telescope is designed to take over where Hubble leaves off, looking back through space-time to an epoch when the first stars were born, the so-called cosmic dark ages following the Big Bang 13.8 billion years ago. Its 18 gold-coated hexagonal primary mirror segments will see the very first galaxies in the universe. And it'll study the atmospheres of distant worlds, looking for the chemical signatures of life. On April the 7th, James Webb's mid-infrared instrument, which was jointly developed by NASA and the European Space Agency, finally cooled down to below 7 Kelvin, that is minus 266 degrees Celsius. Along with James Webb's other three instruments, the mid-infrared instrument initially cooled off in the shade of Webb's tennis court-like sunshade, dropping to a temperature of around 60 Kelvin, that's minus 183 degrees Celsius. But dropping beyond that, getting temperatures down to less than 7 Kelvin, required a special instrument, an electrically powered cryocooler. And it worked. Last week, the team passed a particularly challenging milestone called the pinch point, when the instrument goes from 15 Kelvin, or minus 258 degrees Celsius, down to just 6.4 Kelvin, or minus 267 degrees Celsius. Now, these low temperatures are needed because all four of Webb's instruments detect infrared light. These are light waves slightly longer than those that the human eye can see. Distant galaxies, stars hidden in cocoons of gas and dust, and planets outside our solar system all emit infrared light. But so too do other warm objects, including Webb's own electronics and optical hardware. So, cooling down the four instruments, detectors, and the surrounding hardware suppresses these infrared emissions. And the mid-infrared instrument detects even longer infrared wavelengths than the other three instruments, which means it needs to be even colder. Another reason Webb's detectors need to be so cold is to suppress something known as a dark current. That is, an electric current created by the vibration of atoms in the detectors themselves. The thing is, dark current mimics a true signal in the detectors, giving the false impression that they've been hit by light from an external source. And those false signals can drown out the real signals which astronomers need to find. Since temperature is a measurement of how fast atoms in the detector are vibrating, reducing the temperature means less vibration, which in turn means less dark current. The mid-infrared instrument's ability to detect longer infrared wavelengths also means that it's more sensitive to dark current, and so it needs to be colder than the other instruments in order to fully remove that effect. You see, for every degree the instrument's temperature goes up, the dark current goes up by a factor of around 10. Once the mid-infrared instrument reached a frigid 6.4 Kelvin, scientists began a series of checks to make sure the detectors were operating as expected. Like a doctor searching for any signs of illness, the mid-infrared instrument team have been looking for data describing the instrument's health. They then give the instrument a series of commands to see whether or not it can execute them correctly. Now that the instrument's operating at its correct temperature, mission managers will begin taking test images of stars and other known objects. These can be used as calibration points and to check the instrument's operations and functionality. Mission managers will conduct these operations alongside the calibration of the other 3 instruments on the 6.5 metre telescope, which hopefully will be delivering its first science images by mid-year. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. The Australian state of Victoria has the distinction of suffering the world's longest COVID-19 lockdown. But it was much worse than that. For month after month, the world watched as a politicised Victoria police force bashed and arrested citizens for alleged contravention of the state government's COVID-19 restrictions. Pregnant women were manhandled and arrested in their own homes for their Facebook posts. Religious worshippers were chased across rooftops and detained. Police drones and helicopters spied on people in their own homes. And peaceful protesters were beaten, tear-gassed and even shot at in scenes more reminiscent of China and other totalitarian regimes than in a democracy like Australia. Now, a new study in the journal PLOS ONE has examined how the Victorian government's extended COVID-19 lockdown may have affected the mental health of the state's residents. While trust in police is now much lower, researchers say the lockdown's impact on people's mental health does not appear to be permanent and has showed signs of reversing once the lockdown ended. The authors looked at a long-term national study which surveyed 898 people before, during and after the lockdown and found increased psychological distress coincided with greater social isolation and less work. But it also found that these impacts did reverse once the state's extended lockdown ended. Over 6.2 million people have now been killed by the COVID-19 coronavirus since it first escaped out of Wuhan, China. The World Health Organization says the true death toll is likely to be at least double that amount, with more than 500 million confirmed cases globally. Meanwhile, a study reported in the Lancet Medical Journal claims the most accurate modelling to date suggests that some 18.2 million people have been killed by the virus since it first escaped from China in September 2019. A new study claims people who suffer damage to or a loss of their sense of smell tend to have a higher overall risk of death than people with normal olfactory response. The findings, reported in the Journal of the American Medical Association, are based on data from 11 previous studies of a total of 21,601 participants. Researchers say people with olfactory impairment, that is, a reduction, distortion, or loss of ability to smell, had a 52% higher risk of dying from any cause than the general population. The researchers say this means an impaired ability to smell may be an indication of general health and biological aging, but it will take more research to understand why. Scientists have successfully developed a human-like sense of touch for robots. Researchers monitor the sensitivity of receptors in a 3-dimensionally printed skin to normal pressure, detecting edges, and distinguishing between two close stimuli. The findings, reported in the journal Royal Society Interface, show that while nothing can quite match the touch of human skin, the touch signals sent by this artificial skin are remarkably close to real skin. Researchers hope to use this technology to develop better prosthetics and to build more complex robots which are capable of gently handling various objects thanks to this improved sense of touch. Well, beyond doubt, the biggest technology story this year so far is news that the world's richest man, SpaceX and Tesla boss Elon Musk, has bought a 9% stake in social media giant Twitter and has made a $41.4 billion offer for a majority shareholding in the company. Musk says he's concerned about the growing lack of free speech and balance on the popular platform. Twitter began being mostly used by journalists and politicians as a sort of de facto news wire service, with interesting background information thrown in. Although never considered accurate, journalists, including myself, used it as a tip source. When a story initially appeared on Twitter, we would then follow up by ringing the correct source to confirm or deny. And for that, Twitter was great, and so it quickly caught on. The problem is, as it grew, it evolved into a platform used by gossips and trolls with an agenda, often when they were drunk, and mostly from just the one side of politics, with fake accounts and bots then used to amplify their propaganda. Twitter eventually spiraled down into the toilet. It deliberately blocked legitimate news stories, falsely claiming they were fake in the build-up to the last US presidential election, only to later admit that they were really true after the election was over. Today, reputable journalists regard Twitter as little more than the electronic equivalent of the toilet cubicle wall, and no longer representative of true public opinion. Watching the speculation over the strategy behind Elon Musk's move is fascinating, and those of us in the bleachers are watching with anticipation. Pass the popcorn. Joining us here in the grandstand is technology editor Alex Harov-Reutt from ITWire.com.
Well, a lot of people seem to have tried to create a Twitter clone that would outdo Twitter. You've got things like Parler and Getter and Trump's Truth Social. None of them have quite resonated or taken off. In fact, Parler was shut down, and I notice I get ads from them trying to sell you stuff that is reminiscent of just spam emails, and they're trying to sell various different things. So they seem to have really disappeared, and Twitter is the place for all the banning that Twitter has done and shadow banning of Trump and of others. Twitter is the place that gets the most traction, and it's interesting to note that the Russian Ministry of Defense and other global world leaders and dictators are quite welcome on Twitter, but Trump is not. And I imagine that Elon Musk, who has pointed out that Twitter is supposed to be like a town hall or a town square where free speech is meant to be welcomed, especially in the US. And with Twitter having originally said some time ago that it was the free speech wing of the free speech party, well, we can see how false that is. And Elon Musk is reported to have $392 billion US. So to spend around about $3 billion to acquire 9.2% of Twitter is just a drop in the bucket for him. And he can make a real impact. There was, he actually turned down the chance to go on Twitter's board because that would have limited him to a maximum 14.9% stake as a director. And Elon Musk removed some of the tweets that noted that, should Twitter's HQ be given over to the homeless because no one at Twitter appears to be using it because a lot of people still want to work from home. There was Substack who sort of said, hey, Twitter employees, if you want to quit Twitter because Elon is taking away your ability to shut people down, then please don't come and work here. We don't want you. And there was a tweet that said that Elon turned down the ability to be on the board because he knew that they would ask him basically to shut up. And there was a smiley face tweet from Elon, and some of these tweets have now been deleted by Elon, and because he knows when it's time to delete things. And there is, of course, a shareholder revolt in the sense that some investors claim that they couldn't cash in on Elon's purchasing of the shares because he didn't indicate that he had purchased the shares within the time frame, within the 10 days that he's made that particular purchase. So we'll see how Elon deals with that. He's had problems with the SEC before, and he's clearly a bit of a provocateur. But if anyone's going to shake Twitter up, it's Elon. He is now free, if he wishes to purchase more of Twitter. And if he can restore some of its free speech nature, then that would be a good thing. And with Twitter the main game in town, if you can't beat them, join them by buying them out and then changing them from the inside. That's what it seems like to me.
That's Alex Harov-Reutt from ITWire.com. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.